Learning Objective 2.7 is about cumulative frequency distributions and cumulative frequency polygons, and it's exactly what it sounds like. Cumulative is a total or the sum of something, and so we are looking at the sum of the frequencies here. Now we usually use this to show data, how many data exist below a specific upper class boundary. So let's take a look at an example. So we are still using this example that we've used for all of the other problems. A researcher wanted to do a study on the number of miles employees in a large warehouse walked during their shifts each day. What percent of employees walked less than 6 miles a day? So we are going to use a cumulative frequency distribution and then create the associated polygon to go with it. The first thing we have to do is find the cumulative frequency. This is very straightforward. All you do is you start with your first one, and that our first frequency is 3. And then the second one, you add 3 plus, so you add the previous plus the current one, which gives us 13. And then the next one, you take 13 plus 6 is 19. And then you take 19 plus 2, which is 21. And then you take 21 plus 3, which is 24. Notice how my cumulative frequency should equal the total number of data points I have, which is 24. So that's a good start right there. When your cumulative frequency at the end adds up to be your total, you know you're on the right track. Okay, we're ready to work on our cumulative frequency polygon, so let's get started. You'll notice that I've already set it up here, and I want to walk through how I did that. So on our x-axis, we have to scale the upper limit of each class along the x-axis. And what that means is we go over here to our class limit, and the upper limit is the largest number, okay? It's just the highest point, so 4. In this case, then 6, 8, 10, and 12. Now the reason that I have 2 on here is that we are going to anchor our cumulative frequency polygon, and the class that would be before this would be 0 up to 2. So 2 would be that upper limit for that one. So that's why we have that on there. Then let's look over here at the vertical axis. We've got our number of employees. Now, since this is cumulative, we have our total number of employees, which is 24. And then I just distributed it evenly. You might do it differently. You might do 1, 2, 3, 4 up to 24. You might go by 2s. That's fine. Just find something that makes sense and do it that way. Then on the right-hand side, I have the percent of employees. This takes a little bit of calculations, but it's not hard. So all I calculated was 100% obviously is 24. And then I just do it in my head. Half of 24 is 12, so that's 50%. Half of 12 is 6, so that's 25%. And then if I take the 25% and the 50%, so 6 and 12, I get 18, and that's my 75%. You can use a calculator, that's fine. If you can do it in your head, great. Otherwise, use a calculator, use your resources. So now let's go ahead and get started with plotting. As I said before, we are going to start and anchor our cumulative frequency polygon at 0, 2. Then we want to know how many employees total did up to 4 miles, and that would be 3. The next one is 6 miles, and we have a total of 13. Then we have 8 and 19. We have 10 and 21. And we have 12 and 24. Now we can connect our lines. And we have our frequency polygon. Now, one thing I'm going to adjust here is I'm going to pull this over, okay? And that is our frequency polygon. Now we can answer our question, what percent of employees walked less than 6 miles a day? So we go to the number of miles, we go up here. Now if our chart was extremely precise, like we did it in Excel, then we would have a really good estimate. We know it's somewhere between 50 and 75%. And of course, we can calculate this mathematically as well, because we know that it's 13, so we would do 13 divided by 24. We would get our calculator and we would do 13 divided by 24, 54.17%. So let's just round that to a whole number, make our lives easy. So 54% of the employees walked less than 6 miles in a day.